first one together. Okay. So 12 times x plus 2 over 4 minus x minus 1 over 3. Okay, so I'm going to distribute my 12 to both terms here. So this is 12 over 1 times x plus 2 over 4. That's a 2, and it doesn't look like a 2. 2 over 4. And then minus 12 over 1 times x minus 1 over 3. All right, you could go ahead and distribute your 12s, right? But instead, I'm going to try to make my life a little bit easier and do some canceling ahead of time. Here, in that first term, I have a 12 on top with a 4 on the bottom. What is 12 over 4 reduced to? 3. 12 over 4 is actually 3, right? So that reduces, and you end up with 3 times x plus 2. In the next term, we have a 12 on top and a 3 on the bottom. What is 12 over 3 reduced to? 4. Yeah, so I have minus 4 times x minus 1. Then you can distribute your 3 and your 4 and combine like terms. So I have 3x plus 6 minus 4x plus 4. That's tricky because you have minus 4 times minus 1 gives you positive 4. And then combine like terms and you get negative x minus 2. There are lots of other ways to approach that problem, and you'll still get negative x minus 2. So if you didn't do it that way, totally okay. There are lots of other approaches. Yeah. Yeah, I made a mistake. Plus 6 plus 4 is plus 10. Thank you. Maybe that's why it was in my head. All right, so there's lots of ways to get to that negative x plus 10. I saw people trying to simplify what was in parentheses first by getting a common denominator. That's totally okay. There are other ways to do it too. Okay. All right, so I'm going to skip the next one because I think that most people can solve that without a problem. And then we'll do b together. Okay. So I want to solve this equation. It's got some denominators. If you were just trying to add those 3 fractions together, you've got denominators of 4, 6, and 3. What would the common denominator be? 12, yeah. The least common multiple of 4, 6, and 3 is 12. All right, so let's make them all have the same denominator. If I want to turn a denominator of 4 into a denominator of 12, what do I have to do? Multiply by 3 over 3. So this is going to be 3 times x plus 1 over 12. And if I want to turn a denominator of 6 into a 12, what do I need to do? Multiply by 2 over 2, so this becomes 2 over 12. And then denominator of 3, to turn that into a denominator of 12, you have to multiply by 4 over 4. So this is going to be 4 times 2 minus x over 12. All right, so the reason I did that is that now all my denominators are the same. I'm not going to try to add or subtract or combine like terms or anything. I'm going to get rid of those denominators. They're now all the same, so I'm going to use the fact that I can do anything I want to an equation as long as I do the same thing to both sides. Right? So I'm going to use that to my advantage and say, okay, then I'm going to multiply both sides of my equation by 12. If you have 12 times some stuff and then you divide by 12, what happens to the 12s? They cancel. 12 times something and then dividing by 12, the 12s undo each other. The one on top, one on the bottom, they cancel. All my 12s are going to cancel. Right. So all I'm left with is 3 times x plus 1 equals 2 plus 4 times 2 minus x. No more denominators. And then I'm not going to finish solving it because I think that you could all do that. The trick is the getting rid of the denominators part. Any questions? All right. Oh, look, it's the same problem. Okay. So it's easier to solve linear equations when they don't have fractions in them, right? Generally, it's easier to do problems that don't have fractions in it. So the goal, whenever you see fractions, is to get rid of them. So first, create a common denominator, and then get rid of it by multiplying both sides by it. So I'm going to have you ignore all the directions here, and we'll just do this again. Okay, I want them all to have a denominator of 12. So this became 3 times x plus 1 over 12 equals 2 over 12 plus 4 times 2 minus x over 12. This is the problem we just did. Then you can get rid of the 12s by multiplying both sides of your equation by 12. And if it helps you to visualize, it might help to write that as 12 over 1 so that you can see you have a 12 on top and a 12 on the bottom. All the 12s cancel. And we're left with 3 times x plus 1 equals 2 plus 4 times 2 minus x. All the fractions are gone. Then just distribute and solve. So I have 3x plus 3 equals 2 plus 8 minus 4x. Get all my x's together, so I've got 7x equals 10 minus 3 is 7. Divide by 7 and you get x equals 1. Okay, so we just solved what's called a rational equation. That's just an equation that has fractions in it. Okay. But my denominators were just constants, 4, 6, and 3. They were just regular old numbers. So the rest of today's class, we're going to be dealing with rational equations where the denominators aren't just numbers, but they are expressions involving x. So the procedure for solving them is very similar to the one we just did. You still have to come up with the lowest common denominator, give everything the same denominator, and then get rid of it. So first thing we should do, one very important difference is that we have to remember to exclude any values of the variable that would make a denominator 0. Okay. So when I start with this equation, what values of x would make any denominator 0? 0 and 1 for sure, yep. I definitely can't put 0 in because 1 over 0 would be 0. 0 squared minus 0 is 0. 1 squared minus 1 is 0. Are there any others? So negative 1 squared minus negative 1 ends up being 2. Yeah, so it was a good thought though. So just 0 and 1. We just have to make sure that x can't be 0 and 1. Now we go about solving. Okay, so first thing we do is we try to come up with a common denominator. And before even that, we want to factor everything possible. So I have 1 over x. That's totally factored. And I'm going to make bigger lines so that I can build my common denominator. plus 1 over x squared minus x. How would I factor that? Close. X times x minus 1. You just pull out the GCF. Both terms have an x in it, so you can, it's like reverse distributing. So you pull out the x, and you're left with x minus 1. So you can see that they're equivalent, because if I distributed that x, I would get x squared minus x. And then that equals 5, big line, over 1. Okay, so now I would like to build a common denominator. I need all of them to have the same denominator, and then I can get rid of it. All right, so common denominator. So the way we build it is each fraction looks at its neighbors, looks at the fractions near it, and wants what every other fraction has in its denominator. So my 1 over x, it's got an x in its denominator, right? And it looks at its neighbor and it's like, oh, you have an x, I have an x, that's cool, right? And then it says, but you have an x minus 1 and I don't. I'd like an x minus 1. Okay. So we have to give an x minus 1 to this denominator. And we also have to put it in the numerator. Otherwise, we'd be changing the value of the fraction. All right, and then it looks at the last fraction, and it says, oh, you have a 1. Does this first fraction have a 1? Yeah, because multiplying by 1 doesn't really change anything. So you could, there is an imaginary 1 there, so we don't have to give it another one. So now my first two fractions have the same denominator. My last fraction needs to have the same denominator as the first two. So it looks at those two and it's like, oh, you guys have an x and an x minus 1. I need those. So we have to give it both of those. Now everybody has the same denominator. So the whole purpose of getting the common denominator is so that we can just get rid of it, right? Once everybody has the same denominator, multiply both sides of the equation by that denominator. Okay, and the whole purpose of that is that it just makes all the denominators, poof, disappear. They're all going to cancel. Cancel, cancel. Cancel, cancel. Cancel, cancel. Everything cancels. So I'm just left with x minus 1. Oops. Plus 1 equals 5 times x minus 1. No more denominators. Minus 1 plus 1, those go away. X equals, I'm going to multiply this all out and I get 5x squared minus 5x. Ooh, anybody remember how to approach solving a quadratic equation? What do you need? You could use a quadratic formula, but before you can apply it, you could factor it, but before you try to factor, one side has to be 0. Yep. So we could do, either of those two methods will work, but one side has to be 0 for both of them. So I'm just going to subtract x from both sides. So I have 0 equals 5x squared minus 6x. I'm going to factor it today. You can use a quadratic formula if you want. There's a little hidden plus 0 there. And then your a would be 5, and your b would be negative 6, and your c would be 0. You could use the quadratic formula. But because there's no c, factoring is going to be a little bit easier. So there's an x in both terms, so I'm going to factor that out. And I'm left with 5x minus 6. All right, now that I've factored, the purpose of that is that when you have two quantities multiplied together, the answer is 0. At least one of them has to be 0. One or both of those quantities has to be 0. That's the only way you can get 0 as the answer to a multiplication problem. So either x equals 0 or 5x minus 6 equals 0. And in this case, x is 6/5. Before I circle stuff, go back up at your list of things x cannot be. X cannot be 0 or 1. So we got 0 as a solution. X that out. X cannot be 0. X equals 6/5 is going to be our only solution. So summarize, build a common denominator so that you can get rid of it. Right? Build a common denominator and then get rid of it. Questions? All right. I'm going to have you start your activities, solve and check. Let me know if you have questions. I'll come around and help. Okay, so I just wanted to make sure I get to remind you that Project 1 is due Friday. Okay, so Project 1 is the GeoGebra project. Though you can opt for a grading option where projects don't count, I really, really want everybody to do Project 1. That way you won't be trapped into a grading option after the first test. Okay. And then next week, we've got Quiz 1 coming up, so know that that's coming also.